Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Step on inside as we conclude Chapter 2 with the Chapter 2 Test and Cumulative Assessment. 16 questions, I think, in the first bit, and 10 in the Cumulative Assessment. That'll cover Chapters 1 and 2 in total. We'll see what kinds of questions they have all told. I'll break this up into the two separate parts in the description section down below. If you want to find the links to those certain parts in the PDFs, you can download them separately because I know some people just focus on one part or the other. This is a case now where we've done the entire sections, we've done the reviews. This test stuff may be a little more enriching. They may have different kinds of questions. For me, it's less teaching, more doing as a whole. Hopefully we can get this done in kind of shorter time, although some of the questions are still rather robust, especially solving systems and, you know, when they have big word problems and things like that. So check out things down below if you need to download anything or find timestamps to certain parts. I'm going to start with the Chapter 2 test portion. Away we go on numbers 1 through 16. Let's start with numbers 1 through 3, where we are going to graph the function and its parent function, then describe the transformation. Now, if we're going to graph these guys, I'm going to go ahead and copy and paste this kind of graph in here. If you'd like to download these graphs, you can go ahead and do so as well. So I'll get these set up. This is number 1, f of x equals absolute value of x minus 1. Now, the parent function to this is just absolute value of x, which has a vertex at the origin. It has a rise and run of 1 in both directions, up and to the right, up and to the left. So, like so, like so. This is, again, the parent function. The transformed version of this, the x minus 1, we're going to go 1 to the right here. This vertex is at 1, 0. It's basically the same graph. It's got a slope of 1, all that kind of stuff. That's the only transformation that's happening, actually. It's just a translation 1 unit right. Otherwise, it's the same graph, right? Rise, run in that same direction, kind of like that. So it's exactly like that. Describe the transformation. F is the graph of F is a translation 1 unit right from its parent function. Like I said, probably a little more doing, less teaching, as long as the speed of what I do is, or as long as what I talk about is equivalent to the speed of what I'm doing. So we move on to number 2, f of x equals 3x quantity squared. Now there are a couple ways that we can talk about this one. What I will begin with, however, is the parent function. Let's start with the parent function. This is a quadratic function, f of x equals x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Squaring the negatives also turn positive, reflect across the axis of symmetry. That is the y-axis. This U-shaped parabola is our parent function, f of x equals x squared. Now this next function, as you can see here, has no pluses or minuses in any sort of way, no translations. However, there is some sort of stretch factor, or perhaps in some cases, a compression factor. And you might not believe it until we actually talk about it a little bit more. So with number 2, we do have f of x equals 3x quantity squared. Now, in the way that it's presented, we can look at the thing inside the function as a horizontal component. This guy right here, this 3, is representing a horizontal stretch or compression. And in this case, it's actually not a stretch, it is a compression. The graph of f is a horizontal compression or shrink by a factor of not 3, but 1/3. Our x's need to be a third of the size that they should have normally been because they're about to be 3 times larger than they were. So the tricky part about this is if we use the 1/3 compression, so we take a third of the horizontal bits. Instead of 1, 1, 2, 4, 3, 9, we got to take a third of 1 and go up 1, a third of 2, a third of 2 and go up 4, so 2/3. And a third of 3, which is 1, and go up 9. So this is the horizontal compression of this guy right here. That's how this graph would work. And normally if I have one of those taller graphs, I could probably plot more points, not many more. Actually, just one more than that. So it's going to be skinny no matter what we do. Very, very skinny, as you can tell. Now, there's another way we can work out and talk about this number. This 3. We can square the 3. We can square the 3. We can get it outside of its parentheses. 3 squared is 9, so we could rewrite this as f of x equals 9x squared. Now 9 is no longer inside the parentheses, no longer part of the function, so it's no longer a horizontal component, it's now a vertical component. You can describe this as the graph of f is a vertical stretch by a factor of 9 from its parent function. And I didn't mention last time from its parent function. I hope that's okay. Is this any different from the other graph? No, it's the same graph. take a look at this. Vertical stretch, instead of going 1, 1, we're going 1, 9, and that's this point right here. And negative 1, 9 like that. Now, I didn't hit the other points in between, which is probably crucial that I do, but it's the same graph. And that's why I wanted to say you can go one way or the other on it. Just make sure you know what you're doing, make sure it's still a parabola. And that's it. All right, let's go to number 3. Number 3 we have, and listen, I don't think we had a question like that on the review, so that is a different kind of question to me. So f of x equals negative 1/2 x minus 4. I don't have much to say on the graphing front of this. It's not significantly unique from anything you haven't done since IM1. This is slope-intercept form, where you have a y-intercept of negative 4 and a slope. Oh, let's start with the parent function, actually. It's a rise of 1, run in 1 with the y-intercept of 0, so it looks a lot like this guy right here. It is this guy right here. And I'm going to make it black. Give me a second. There we have it. Okay, now this other one has a y-intercept of negative 4 and a slope of negative 1/2. That's down 1, right 2, down 1, right 2. If you want to go down 1/2 and over 1, you could, I suppose, but then you're just going to hit it like that. So same line, right? And we continue that line the other direction. I'm going to imagine that I did do exactly that, just like that. Okay, so there is this line. Now, how does it compare? Or how do we transform it? We do several things. 3 things, actually, specifically. One is a reflection. This thing flipped over like that. So the graph of f is a reflection in the x-axis because we are multiplying the negative by x. The negative is multiplied by your function. The black line is y equals x, so we're doing all that. Reflection in the x-axis. And a vertical compression, or shrink, let's say shrink this time, by a factor of 1/2 from the parent function of y equals f of x, or y equals x, followed by a translation 4 units down. So this thing flips over from, here to there. It compresses itself like that, and it goes 4 units down. That's where we get the 3. All right, let's go to numbers 4 through 6. Match the transformation of f of x with its graph, then write a rule for g. They don't ask us to explain why, so I won't put actual explanations. I will just go ahead and, I guess, probably just copy and paste which one goes there. So the first one says g of x equals 2 times f of x plus 3. The original equation is f of x equals x. So, this equation is going to be g of x equals 2 times x plus 3. So we're looking, that's a linear equation. All these will have to be linear equations. They're all based off this one thing. So we're looking for a slope of 2 and a y-intercept of 3, and that's going to be b right here. So this one is b. Doesn't say to explain why, but it did just say write a rule for g. If by the rule they meant write the equation, this is it. So I think that's all that they mean to ask. So we're just substituting x for f of x. Kind of a weird set of questions because the other two are the exact same function that we're basing this off of. So number 5 is g of x equals 3 times f of x. Kind of is weird questions. 3 times f of x minus 2. So the rule is going to be 3x minus 2. Is that what they mean? Is that all they mean? I guess so, because they didn't say describe the transformation. So that's the rule there. What's 3x minus 2? Slope of 3, y-intercept of negative 2. That's going to be c. So that's this guy right here. I don't really have much to do on these problems. I apologize. That's what the questions are. And that's this one. And then the last one must be a. Let's see if we can tell. On number 6, g of x equals negative 2 times f of x minus 3. When f of x equals x, it's going to be g of x equals negative 2x minus 3. Which means a slope of negative 2 and a y-intercept of negative 3. But that slope of negative 2 is the true giveaway that this one is going to be a. So let's get that one in, copy, and paste, and resize, and finish. I believe that's it for numbers 4, 5, and 6, unless I'm missing something else. I think that's just all you do. There you have it. All right, let's keep moving forward. Number 7. Graph f of x equals 8x squared minus 4x plus 3. Label the vertex and axis of symmetry. Describe where the function is increasing and decreasing. This chapter test thing isn't going in order of sections, and I'm not here to name all the sections for you this time. I'd probably forget what they are. If I were to guess, I believe this is out of section 2.6. Section 2.6 on characteristics of quadratic functions. But yeah, now we're leaping a little forward in time here. So we got f of x equals 8x squared minus 4x plus 3. Now, they kind of intend us to go out of standard form. I did cheat and take a sneak peek at what chapter 3 has to do with a little bit. They involve factoring, so they don't expect us to factor or do completing the square, yada yada. So we're going to graph out of standard form, which means we need the vertex, which means we need the axis of symmetry. X equals negative b over 2a. So negative b over 2a. Oh, this isn't going to be a pretty number. 4 over 16, which is 1/4. 1/4 is also 0.25. We'll make sure to kind of look at what that's going to be in a second. Now we got to substitute 1/4 for x and get the y value of the vertex. And then we will get some other information after that. Okay. 1/4 squared is 1/16th, and 8 times 1/16th is 1/2. Minus 4 times 1/4 is 1. 1 minus 1/2 is negative 1/2. Plus 3. So negative 1/2 plus 6 halves is 5 halves, or 2.5. So we have 1/4, or 0.25, comma 5 halves, or 2.5 as our vertex. I'll write them as the decimal thing. That's a little easier for you to look at. I don't know which one's easier or harder. In these sections, I really did use the tall graph paper, so I'll do the same thing. Copy that, paste that over. So we're going to graph this thing tall as well. The axis of symmetry is x equals 1/4, or 0.25. It's not a very pretty looking number, but we'll go with what we got. So I'm going to do it about right there-ish, just a quarter way over from that, and that's where the vertex is. And 2.5 units up is like that. Now this graph is very tall anyway. The stretch factor is 8, but I do want to keep in mind this y-intercept here of 3. I want to plot that guy. So the y-intercept is 3. It's right there. It's just very close to this. That means there's a point I can reflect across. That's right there. See, 3 is just a quarter, or x equals 0 is a quarter of the way from x equals a quarter. So another quarter away is right there as a corresponding point. This isn't going to be a very pleasant graph by any stretch. 1 over 8 up is what I can do here. So 1 over is at 1 1/4, and 8 up is at 10 1/2. So I can get that guy about right there. And then this guy on the other side, 1 over 8 up is like that. Really best as I can do with this graph. There's really not much more I can actually discuss, describe, or talk about. If I went 2 over, I'd be going 4 times 8 up. I'd be going 32 up, and that's not something I can fit. I can't fit it by changing scale really either. These are already on decimals. It's going to be pretty tough to do. So the problem just is what they made it to be. So unlike numbers 4, 5, and 6, number 7 just throws you for a little bit of a stranger wrinkle there. So there's the graph. They said label the vertex and axis of symmetry. I did give you the axis of symmetry, x equals 1/4, so I'll label it here. And I did give you the vertex, and I'll label it right there. So best I can do for now on that. Now, describe where the function is increasing and decreasing. It's decreasing. It's going down to the left of x equals 1/4, and it's increasing to the right of x equals 1/4. So I'll state that down below. Increasing when x is greater than 1/4, or 0.25, axis of symmetry, and decreasing when x is less than 1/4, like so. So there's that, axis of symmetry is there, and we're good. All right, that's number 7. Let's jump on to number 8. Let's see what it says. Let the graph of G be a translation 2 units left and 1 unit down, followed by a reflection in the y-axis of the graph of that, it's not even vertex form, but f of x equals 2x plus 1 quantity squared minus 4, right rule from G. All right, this one has a couple things involved. Let's get it started. F of x is this guy here. Now this one, I said it's not truly in vertex form. It's because that 2 isn't really factored out of this thing. So I don't know if the final G equation should be in factored form or standard form. I'll just let it play like it's supposed to. I don't know. We'll see. I'm going to start with an h of x interim function before I get to the g of x. Let's start with the translations. 2 units left and 1 unit down. Now 2 units left means we have to take our f of x and we have to go x plus 2 inside the function. 1 unit down means we got to subtract 1 outside of the function like that. So now when we substitute into here, we're going to get, anywhere we see x, we're going to put an x plus 2. So in parentheses, x plus 2 like that. And outside of this function that we're going to write, we're going to subtract 1. So it's kind of like here's the function, and then outside the function is a minus 1. Inside the function is replacing x as x plus 2. Now I can distribute that. Whoops, let's keep using blue. And we get 2x plus 4 plus 1 is 2x plus 5. Quantity squared minus 5. So there's that version of it. I'll still leave it in that form for now as long as it seems like that's what they were doing before. So I'll do it as well. Followed by a reflection in the y-axis. So now g of x is what I can get to now. That was the two translations. And for g of x, we're going to reflect in the y-axis, which means make the x negative inside the function of your h of x function. So g of x is going to look like 2 times negative x plus 5. Remember, just replaces x minus 5. Which is negative 2x plus 5 quantity squared minus 5. So that's not my favorite appearance of an answer. Generally, I wouldn't want to do something with that unless, you know, they did it for absolute values. Maybe we should factor out the negative. So if I factor out a negative from here, I get 2x minus 5 like that. And then the thing is, normally we'd be taking the absolute value of this negative 1. Remember, this is a negative 1 that's factoring out. I want to square that negative 1. And negative 1 squared is 1. Basically, it becomes a 1 on the outside, and now 2x minus 5 is inside there. So I think that's the best appearance that I'm going to write given that f of x was also in that form. And I don't know what to call the form. It's not exactly vertex form, but you know, it's something that's close enough to it to make sense of it. Factoring out that negative is something you can do, and it does affect what that value is. And you can also factor out the 2. I don't know if it doesn't seem like that's something we're really in the realm of doing right now. But factoring out the negative 1 and squaring it, it's possible. It's allowed. All right, let's keep moving forward. Let's go to number 9. And 10. Write a linear function or quadratic function that models the data. So if it has a constant rate of change, let's just look at the x's. Note that both x's on numbers 9 and 10 have a constant increase. On the x's here, they're going up by 1s. On the x's, sorry, this is going to be blurry. On the x's on number 10, they're going up by 2. So at least that one is consistent. Now let's take a look at how the y's compare here. This is a plus 4, plus 4, plus 4. Constant first difference means this is a linear function. So because it's a linear function, we basically got to find the slope and the y-intercept. The y-intercept is the value of y when x equals 0. That's going to be 7. So b is 7. The slope is going to be the rise over the run. We are rising 4 and running 1. So in slope-intercept form, this equation is going to be y equals 4x plus 7. That's it. Number 10 is likely a quadratic. Because, you know, we got to get our practice in. That's really what this chapter's based off linear functions as well, but quadratics are the ones you are learning maybe for the first time. So with this one, we are subtracting 13, and then 21, and then 29, and then 37. Not a constant difference, but this is 8 less than the previous number. This is 8 less than the previous number. This is 8 less than the previous number. The second difference is constant. That is indicative of a quadratic function. Now, quadratic functions can be written in one of 3 ways: vertex form, intercept form, or standard form. If we had the x-intercepts, values of x when y equals 0, we could do that. Here's one of them, but I don't have the second one. So I don't probably want to use intercept form. I don't see a vertex as a for sure anywhere here. So I'm going to go off of 3 different values, like maybe these 3 right here. 2, 0. That's x, 2x, 0 for y, 4 for x, negative 13 for y, and etc. Write a system of equations off of y equals ax squared plus bx plus c, and solve that system for a, b, and c. So a times 2 squared plus b times 2 plus c equals 0. A times 4 squared plus b times 4 plus c equals negative 13. And a times 6 squared plus b times 6 plus c equals negative 34. So here's our set where we can work this thing off of. Let's give it a shot. Eliminating c is the best go-to here. I could do something like make the first one completely negative, changing these signs, negative, 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 and 0 is just 0. And let's add equation 1 with equation 2 and equation 1 with equation 3. That's a version that we can take care of, get rid of the c's, and then do something with the rest. So let's do equation 1 and 2. Added together, this will now be 12a plus 2b equals negative 13. And then let's add equations 1 and 3, the modified one at least, and we get 32a plus 4b equals negative 34. Now in this bottom equation, I can divide everything by 2. If I wanted to eliminate b's, I could divide everything by negative 2. So this will be negative 16a minus 2b equals positive 17. And now ignoring this equation, I can now go down these lists right here, combine them using elimination method basically. I got negative 4a, b's cancel, and I got positive 4, so a equals negative 1. Now I use that a to solve for b. I can use any of the equations under the sun that I got, that, well, actually one of these two, I guess. Let's use 12a plus 2b equals negative 13, so that's negative 12. Whoops. Negative 12 plus 2b equals negative 13. And 2b equals, add that, negative 1. So b is negative 1/2. So, all right, a fraction, not a terrible fraction, but still a fraction nonetheless, right? Something you just got to be kind of comfortable with. And then for c, let's go ahead and plug in a and b in here and find c. Let's use the 4a plus 2b plus c equals 0. So 4a, separate that. 4a plus 2b plus c equals 0. That's negative 4 minus 1 plus c equals 0, or negative 5 plus c equals 0. C equals 5. So we have all three of a, b, and c. If we were to write the equation out of this in standard form, it would be y equals ax squared, so negative 1x squared, plus 2b, or plus bx, plus c. There's a version. If you want to write negative 1/2 as a decimal, as negative 0.5, that's fine. But that should be our equation for that one. And that's all they asked us to do, right? They said identify what kind of equation, come up with the function. Yep, that's it. All right, let's go on to numbers 11, 12, and 13. Another set of systems of 3. It's possible we're going to get some fraction answers like this. It's possible we'll get no solution, infinite number of solutions, or very clean solutions. I have no idea. Let's take a look. Negative 2x plus y plus 4z equals 5. And you want to start to think about a strategy you want as well. When I start to look at these, minus z, I'm thinking out loud while I'm doing it, while I'm writing it out. 4x plus y. Nothing very obvious comes to mind. Eliminating x, y, or z will do. How about the y's? If I change the signs of the top equation, multiply by negative 1. Let's multiply it by negative 1, and now the equation says 2x minus y minus 4z equals negative 5. And now I can align these two together, combine those two, and the y's will go away. So this is going to be scrappy work. Apologies, but this is my plan. 6x minus 10z equals 6. If I divide everything by 2, as I generally like to do, I get 3x minus 5z equals 3. Now let's eliminate the y's with these two. I'll multiply by negative 3 instead. I'll just write this down below. I have x plus 3y minus z equals 2, and let's multiply that by negative 3. We'll get 6x minus 3y minus 12z equals negative 15. Okay, so add down those lists. You get 7x minus, I guess, 13z equals negative 13. I trust that those are decent. Now, these numbers don't really pan out for me in a decent way, though, right? Let me make sure I multiplied that all right. 6x minus 3y minus 12z is negative 15. Yeah, I think so. Okay, so I got this equation here, 7x minus 13z equals negative 13, and 3x minus 5z equals 3. Still a long way from solving this in the end, right? So far, it's not looking like a good set of values, basically, right? These are still, if I want to use elimination method to now solve this one, I got to find a least common multiple of 7 and 3, or 13 and 5. Might as well do 7 and 3. Let's multiply the top equation by 3. Times 3, we get 21x minus 39z equals negative 39. And the bottom equation times negative 7. Let's do that. So we get negative 21x plus 35z equals negative 21. So x's eliminate. For z, we're going to get negative 4z equals negative 60. Therefore, z equals 15. So at least it cleaned up. You know, I trust my answer a little bit more seeing that, but it's not like these numbers were clean to begin with. I don't know if eliminating a variable other than y would have made that easier for me in the end, but I got that. Let's now solve for x. Let's use an equation like this one here. We got 3x minus 5 times 15 equals 3. That's 75. And 78, sorry, not 28. 78, so x equals 26. Ugh. At least it's an integer. It's just a weird number. I don't see the number 26 often. All right, what's a good equation to solve for y after? Let's use the x plus 3y minus z equals 2. X plus 3y minus z equals 2. 26 minus 15 is 11. And y is going to equal negative 3. Now this one was not writing an equation out of anything. This is writing the ordered triple, right? Solving the system. And we got 26 for x, negative 3 for y, and 15 for z. There's our ordered triple on number 11. Let's go to number 12. This one, it looks like I'm going to probably use some substitution on this one. So number 12, because I see the first equation, I got y equals 1/2 z. And, you know, automatically in this equation, listen. In this equation, guys, I'm going straight to what? I'm going to multiply everything by 2. I'm not going to plug in 1/2 z into this. I'm going to get 2y equals z. That actually means I'm going to plug in 2y for z for these things. You know what I mean? It actually wouldn't have been too much of a problem. Looks like I could have. Let's stick with it. It's not going to be a problem when I substitute them into here. It'll be fine. It'll be fine. X plus 2y plus 5z, but that's what I tend to want to go for. I want to bust fractions, but these will bust fractions automatically here. Well, except I look at this bottom equation and I'm thinking, let's at least divide everything by 2 or by 3 in the bottom equation, divided by 3, and make that one turn into x plus 2y minus z equals 3. All right, that's smaller. Okay, 1/2 z, y'all, will substitute for y in this equation and in that equation. Obviously, I'm using equations 2 and 3 for that. So equation 2 is now going to say x plus 2 times 1/2 z plus 5z equals 2. 1/2, or 2 times 1/2 is 1, so 1z plus 5z is 6z. So there's the equation, number 2, rewritten with that substitution. Equation 3, we just saw that 2 times y, or 2 times 1/2 z, is z, so I'm just going to write that straight up. X plus z minus z equals 3. Z's cancel out, that's actually good, and we get x equals 3. All right, we actually solved for one of our things. Never mind the whole 2 equations that we can write a system out of. We actually solved for x there, so x is 3. Now let's substitute 3 for x into this equation, and we get 3 plus 6z equals 2. Subtract 3 from both sides, get 6z equals negative 1, so z is negative 1/6. Not the most pleasant of values, but, you know, we'll deal with it. That's our answer on that one. And then the last one we got to solve for is y, and y equals 1/2 of z. So y is 1/2 of z, which is negative 1/12 now. So we get some fraction answers there. It didn't really, I didn't have to go for common denominators or anything like that, but 3, negative 1/12, and negative 1/6. You know, they did say check your solution if possible. I don't know if I'm going to, but if you do, you plug in 3, negative 1/12, and negative 1/6 into your 3 original equations, and you see if they work out. I'm going to trust that what I'm doing is right. I trust my own algebra. But so, yeah, in terms of checking your solutions, that's the plug-in for that. All right, let's go to number 13. On number 13, we have x minus y plus 5z equals 3. By the way, I'll start talking as I'm writing this stuff out. I'll apologize that my work for the systems of equation stuff isn't exactly well organized. It's a progressive flow, and I probably mentioned this at the time that I did it in the section as well, section 2.4. It's a progressive flow of what I have. I'm changing some colors here and there. If I did this on paper myself, it would be just as scattered. For you guys, it should probably be significantly cleaner. But there's very little room I have in comparison to someone else's binder paper. I know if I wanted to teach this truly, like on a whiteboard or something like that, it would probably look a lot better than it is. I also want to apologize. It looks like I was sinking there. Okay, let's go ahead and If we eliminate, I'll probably eliminate y. Let's multiply both the top and bottom equations by 3 to eliminate y that way. I just like not changing signs if I don't have to. So let's rewrite equation 2. I'm going to do this old school. 2 as 2x plus 3y minus z equals 2. And the top one equation is now multiplied by 3, where we have 3x minus 3y plus 15z equals 9. Now when we add down those lists, y's go away, and we get 5x plus 14z equals 11. Nothing can really reduce there, so we'll leave that. Now let's multiply the bottom equation by 3, and let's do the same thing, where we have equation 2 that we're going to combine with to eliminate it. So 2x plus 3y minus z equals 2. And the bottom equation will now say negative 12x minus 3y minus 27z equals negative 24. Kind of rough fit. This is negative 10x, y's cancel, minus 28z equals negative 22. Let's divide those by 2, and we get negative 5x minus 14z equals negative 11. Oh, look at this. Look at this. Look at this. So now this one lines up. Oh, let me just rewrite them. So look at the two equations on bottom. The dividing by 2 actually helped a lot. So 5x plus 14z equals 11, and negative 5x minus 14z equals negative 11. If there's a sign that I'm doing something right, I'm saying this would be it. Everything cancels, which is a way of saying everything becomes 0. I get 0 equals 0, which is a way of saying we have infinitely many solutions. However, we still must say a little bit more as far as, let's do this in terms of one of my variables. Whichever variable I can best get by itself, and I don't really have a best one here. Normally it's a little more obvious. Let's maybe get let's get x by itself. So I look at that top equation, 5x plus 14z equals 11. If I subtract 14z over and divide both sides by 5, I get x equals, and I get negative 14 fifths z plus 11 fifths. Nothing pretty. You could write them as decimals. That would be negative 2.8z plus 2.2. So it's up to you. I'm going to leave them as fractions like that. Now this needs to substitute. So basically as an ordered triple, this is x, negative 14 fifths z plus 11 fifths, like that. And then z is z, and we need to rewrite y in terms of z. So in order to do that, we got to substitute this in for x in one of my equations, probably that top one. Negative 14, okay. So, hold on. Negative 14 fifths z plus 11 fifths. What was the original problem? I'll write it off that. Minus y plus 5z equals 3. Now, if I multiply everything here by 5, that'll help. Bust some fractions, right? So now I'll get negative 14z plus 11 minus 5y plus 25z equals 15. Negative 14z plus 25z, oh, hold on. I have negative 5y. Subtract 11 over, I get 4. Negative 14z plus 25z is 11z. And now I can solve for y here. It's going to look just as, kind of bad as the other one. Negative 5y equals negative 11z plus 4. Divide by negative 5, you get y equals positive 11 fifths z minus 4 fifths. So the infinite number of solutions part looked dandy. It actually looked fantastic. And then this part after kind of looked sucky. So this part I'm going to bring up here to the 11 fifths z minus 4 fifths, like that. That's the y value, the coordinate thing. I know I wrote some stuff on the bottom to kind of finish it off, but this is the answer right here that we're boxing, okay? It's that guy there. It's the final solution set for the infinite number of solutions. Whatever z is, hopefully a multiple of 5, we could determine what x and y are along the way for the ordered triples that are infinite solutions. Okay, 3 more questions from this chapter test portion. We're 34 minutes in. Let's keep boogieing along. Number 14, the graph of a quadratic function f has an axis of symmetry of x equals 3 and passes through the point 0, 6. Find another point that lies on the parabola, then write an equation of the parabola when the minimum value of f is negative 4. We might need room for this one. This is an exploration problem. The graph of a quadratic function has an axis. Let's use one of these here. All right, axis of symmetry at x equals 3. So we got that. The quadratic passes through the point. Hold on. The quadratic passes through the point 0, 6. Okay? Find another point that lies on the parabola. Well, let me tell you, it's one that reflects across here. 3 away, 3 away. Here's another point that lies on the parabola. Here's part of our answer. 6, 6. Okay? So, hope that addresses something. Then write an equation of the parabola when the minimum value of f is -4. Well, in a quadratic, it's either upwards facing with a minimum or downwards with a maximum. In this case, it's upwards with a minimum. When they're talking about minimum, it's on the vertex. So if the vertex has a minimum of -4, or the graph is a minimum of -4, that means it's on the vertex. Your vertex is 3, -4. They are saying write an equation of the parabola. Well, we have 0, 6 as a point. We have 6, 6 as a point. Your choice in which one you want to use on this, but our parabola basically looks like this. I can write this equation in vertex form with all this stuff in mind. What we basically got to find is our stretch factor, because we have our vertex, right? For all I understand right now, my equation is y equals a times x minus h squared plus k. I need to find out what a is here. Now, my personal way that I do this as often as possible is I say, how far do I go over to go up? Normally, when we go over 3, we'd go up 9, 3 squared. Now we're going up from -4 to 6. Now we're going up 10. It's a little bit different, so that's 9 times what is 10, right? 9 times a is 10, divided by that, it's 10/9. So this is the value that I'm expecting for this thing as a whole, and then I can write the answer based off that, if that makes sense. So my equation would then be y equals 10/9 times x minus 3 quantity squared minus 4. So that would be a final. Did they say in... They didn't say what form. So I guess vertex form is satisfactory. Okay, anyway, so how do you get that value without doing what I just did conventionally? Or how do you do it conventionally without doing what I just did? Well, we're going to get to these steps here, but what we first got to do is substitute an xy value into here. You have this as an xy or this as an xy, and I'm going to choose this one. So we're going to get y equals a times 0 minus 3 quantity squared minus 4. Add 4 over, you get 10 equals a times -3 quantity squared, and this is where you get that 9a equals 10. And then you end up getting a equals 10/9, and then we're done. If they wanted standard form, we'd have to do something like expand, because I'm imagining that they're like, hey, use all 3 of these points, do a standard form thing. I'm not going to do the system of 3, but if they wanted a standard form answer, you could expand. This would have a fraction, but you could expand x squared minus 6x plus 9 right here. You can distribute the 10/9 into that. You get 10/9 x squared. 10/9 times -6. -6/9 is -2/3. And you get -20/3. It's kind of weird. And 10/9 times 9 is 10. And 10 minus 4 is 6. So you get y equals 10/9 x squared minus 20/3 x plus 6. I don't know if that's what they wanted, but at least this confirms that we get that 6y intercept that we had before. It's kind of a nice way of just showing that it still pans out. So we have vertex form, we have standard form. I'm not going to dare do a factored form. Actually, factored form might... Oh, never mind. The stretch factor is 10/9. I'm not going to dare try a factored form there. All right, let's keep moving forward to number 15. A passenger on a stranded lifeboat shoots a distress flare into the air. The height in feet of the flare above the water is given by f of t equals -16t times t minus 8. A better way that you could also write that, not write that, but think about it, it's -16 times t minus 8. And I bring all that up because you can treat t as its own quantity there. This is intercept form. You might not see it as that, but it is intercept form. T is the time in seconds since the flare was shot. The passenger shoots a second flare whose path is modeled by the graph. Which flare travels higher? Which remains in the air longer? Justify your answer. Let's start with this graph right here. The other one we'll call g of t, I guess. So this f of t right here, this is intercept form. Your two t intercepts, which would be the same as your x intercepts, are 0 and 8. Time 0 is the time that this thing was shot. So I guess it's shot from like water level, if you will. And then 8 is when the flare hits the ground. So the in-between of this thing, this is what helped me graphing it. The in-between of this thing, the axis of symmetry, is at t equals the average of 0 and 8, which is 4. 0 plus 8 over 2. 4. At time 4, this thing hits a maximum height. So 4 seconds in. It did ask which remains in the air longer. Just so you know, this thing stays in the air for 8 seconds. But at 4 seconds is when it hits a maximum height. So f of 4 is going to be negative 16 times 4 times 4 minus 8, which is negative 4. This is negative 16 times negative 16, which is 256 feet. So this thing hits a maximum of 256 feet in the air. Whereas you get the other... Let me make sure that's right. You get the other one, this g of t. G of t has a max of 196 feet. So the passenger's first flare went in the air longer, went in the air higher. So first flare, the passenger's first flare went in the air higher at 256 feet versus 196 feet. It also was in the air longer. This one, if you can see that graph, it goes from 0, 0 to 7, 0. Its first flare was also in the air longer for 8 seconds versus 7 seconds. And I think that kind of just makes sense that it's going to be in the air longer. It shot up higher. It follows the same gravity rules. So it makes sense that it was also in the air longer. All right, so passenger, let's go. All right, so that's it. Number 16. A surfboard shop sells 40 surfboards per month when it charges $500 per surfboard. 16. Each time the shop decreases the price by $10, it sells one additional surfboard per month. How much should the shop charge per surfboard to maximize the amount of money earned? What's the maximum amount of money earned? All right, this is some sort of quadratic function. Normally they give us a model for this, so I'm going to work this thing out and think about it. A surfboard shop sells 40 surfboards per month when it charges $500 per surfboard. I guess that's a point on your graph you can think about. If that's X and that's Y. Each time the shop, well, we're not doing Y as how much you charge. Y is going to be the amount that you earn or profit. I guess how much you earn. It's how much you charge. No, it's how many surfboards you sell versus how much money you earn. So we want Y to be the amount of money earned, and that'll be based off selling a number of surfboards times the price per surfboard. Okay, so those two things. So how many surfboards do we sell? 40 as an initial. However, they said you sell one additional surfboard per month. So if X is the number of surfboards as a total, you start with 40 and you add an additional surfboard every month. It sells one additional surfboard per month. This is the amount of surfboards you can add to it. That's the amount of surfboards. When you multiply by the price, you start with $500 when you sell 40 of them, but you decrease the price by $10 every time you sell an additional surfboard, or the other way around. Every time you decrease $10, another surfboard is sold. So let's do the 10 times the number of surfboards like that. That way, when you sell 3 surfboards, you're taking $30 away, or vice versa. So this is number of surfboards. I know that the way I'm saying it makes sense in my head. I think I'm saying it backwards for you guys, because number of surfboards you sell is actually based off price you set, not the other way around. So this is price point per surfboard. When you multiply those things together, you will get amount earned. And we're trying to maximize the amount earned based off getting a certain number of surfboards here. So you could argue this is factored form. It kind of is, but not really. You'd have to do some things to it, or intercept form. You have to do some things to it if you wanted to. For instance, I could factor a negative 10 out of here. Let's write this one first. If you factor a negative 10 out, you get x minus 50. And then here you have an x plus 40 on this other quantity. So intercept form will work out on this thing as long as these are truly two x's. You could also do standard form if you wanted to expand this. I'll leave it like that unless they want us to write a standard form model. How much should the shop charge per surfboard to maximize the amount? What's the maximum amount? So let's do this. Let's get the axis of symmetry, x value. We basically need the vertex, but there's one more thing we'll still need, and that's why this function is actually so important for me to look at here. But let's get the, hold on, your x-intercepts are 50 and negative 40. We have to average these two numbers here, negative 40 plus 50 over 2, which is 10 over 2, which is 5. When you sell 5 surfboards, you're going to maximize your profit. Now, that was not one of the questions they asked. They didn't ask how many surfboards you sell. They said how much do you charge per surfboard. So if you sell 5 surfboards, the price per surfboard is right here, 500 minus 10x. So price to charge will be 500 minus 10 times 5, or 500 minus 50, which is $450 per surfboard. That will maximize the number of surfboards you sell in general. Now, how many will you sell in general? You got to substitute 5 into the entire equation. So y equals, we already know that's 450, and 40 plus 5 is 45, it's 45. So 45 times 450, I always forget what 45 squared is, so I got to multiply that. I think it's 2025? 2025? I can't remember. 450, but it's 450. So 450 times 45, 2025. So this is $20,250 max profit, max earnings in a month. So that's the most you can get there. Okay. I'm not putting this to the graphing calculator test, but that's the way I'm working out my model for this stuff here. So once again, creating a model based off number of surfboards, increase one surfboard from 40, decrease $10 from 500 every time you do another surfboard. I used intercept form instead of standard form to get the x-intercept, x-axis of symmetry. But this is just the number of surfboards. And I guess number of surfboards is part of what we can answer, but based off 5, we could get max revenue and price point to maximize revenue. All right, guys, that is the first 16 there, and that is the chapter test portion. Keep sinking just a little bit. Let me get a hit of water. Guys, we're going to go to the cumulative assessment. 10 questions on that. So I'm going to refresh my binder paper page. I'm going to move over to this. I already feel myself sinking again. My chair does this time and time again. So guys, we're going to go ahead and get started on this next set. Number 1, the function g of, there are 4 parts. The function g of x, it's a multiple choice. Function g of x equals 1/2 times absolute value of x minus 4 plus 4 is a combination of transformations of f of x equals absolute value of x, which is a parent function. Which combinations describe the transformation from the graph of f to the graph of g? Okay, before I look at the options, let me tell you what we see here. We have, this is your a value, which is generally your vertical stretch or compression factor. In this case, it's vertical compression. I'm expecting here vertical compression by a factor of 1/2. We also have our vertex on these two at 4, 4, which is a way of saying we translate 4 right and we translate 4 up. So I'm looking for something where they say vertically, the graph of g is a vertical compression. I'm looking at you, I'm not looking at the thing. The graph of g is a vertical compression or shrink by a factor of 1/2, followed by a translation 4 units right and 4 units up. We're looking for something like that. And in that order, the compression first, not the translation first. So let's see. Translate 4 units right, vertical shrink by a factor of 4 units up. I'll tell you what, this is actually allowed. I'm going to go ahead and accept this one, and I'll see if there's a different one. It says which combinations describe. I think there's more than one answer. I'll tell you what. So I'll tell you why this one works in a little bit. It's not what I'd recommend, as I just came off saying you shouldn't do translations first. But going to the right doesn't affect my vertical shrink. Anyway, that one's allowed. Translate 4 units right, 4 units up, followed by vertical shrink. Okay, all these say the same thing, except this says 8, which would be wrong. 4 units right, 4 units up, followed by vertical shrink. That one's not allowed. We cannot translate up and then vertically shrink after and have that be the same. Oh, part D actually may be allowed. This is a tricky question. Vertical shrink by a factor 1/2, followed by translation 4 units up and right. That's kind of what I said first, so that one works. This one technically works, and I'll show you why. Translate 4 units right, 8 units up, followed by a vertical shrink by a factor of 1/2. Okay. These 3 work and B does not. Here's the problem with B, and here's why D works. You're like, how does 8 fall into the mix? It's the same reason why B doesn't work. Remember when I said I don't want to describe translations first? It's because then the shrink applies afterward. See, part A is saying this. Part A says, go 4 units right, okay, like that, and then multiply by the 1/2. That doesn't affect going 4 units to the right, right? If I take a graph and go 4 units right and then vertically shrink it, my vertex is still at where it was before. That's not going to change. And then it says go 4 units up. So that one looks like that. Part B looks like this, and this is why part B is wrong. It says go 4 units right, go 4 units up, and then do a vertical shrink by a factor of 1/2. Look at what this affects. It doesn't, by the way, it doesn't affect the translation to the right, but it does affect the translation up. That's why B doesn't work. A does. C is the one that I generally would have done. The shrink first, boom, then 4 units right, or 4 units up, and 4 units right. So C works. D is like B, but instead it says 8 units up, and the thing is, we get to take half of 8. So this one says go 4 units right, 8 units up, and then shrink by a factor of 1/2. 1/2 times 8 is 4. What did I just do? No! 1/2 times 8 is 4. So D works. All right, that's my quick version explanation of that, writing those things all out. All right, interesting. Number 2. 2 balls are thrown in the air. The path of the first ball is represented in the graph. Okay? I'm not going to write an equation unless they kind of need me to. The second ball is released 1.5 feet higher than the first ball, and after 3 seconds reaches its maximum height 5 feet lower than the first ball. Okay. Write an equation for the path of the second ball. They said second ball, not first ball. So, for the second ball, the second ball is released 1.5 feet higher. Okay, so we're just comparing releases. So, second ball will have a point on the graph. See how this one has a point of 0,5? The other one's 1.5 feet higher, so this has a point that's 0,6.5. That's 1.5 feet higher. After 3 seconds, reaches its maximum height 5 feet lower than the first ball. So the first ball also reaches its max height at 3 seconds in, but it's 56.5. This guy has a vertex at 3,5 feet lower, 51.5. So this is some point on the graph, and this is the vertex. They said write a function. Let's use vertex form to do that. We got our HK, so we can say y equals f of x. We'll just do y equals. Y equals a times x minus h, quantity squared plus k. This time we'll do a substitution. We'll substitute 6.5 in for y and 0 in for x. 0 minus 3 is -3. -3 squared is 9. So a times 9 plus 51.5. We get 9a equals 6.5 minus 51.5 is -45. So we get an a value of -5. Interesting, it's not a -16. Oh, this is, yeah, it's time. Interesting how it's not a -16 thing. It's not a gravity thing. Interesting. Okay, so a is -5, so the model for our equation will be y equals -5 times x minus 3 quantity squared plus 51.5. That's the second ball. That's part A. Part B. Do the balls hit the ground at the same time? If so, how long are the balls in the air? If not, which ball hits the ground first? Explain your reasoning. Well, here's the interesting part. We can... Oh, actually, I take it back. Forget I said anything. But do the balls hit the ground at the same time? So how long are they in the air? If not, which ball hits the ground first? So if they hit the ground at the same time, we want to answer how long they're in the air. Okay, I have the model for the second one already. Let's take second ball. We want to set this part equal to 0. -5 times x minus 3 quantity squared plus 51.5, set it equal to 0, and we want to solve for x. Now we want to find the positive value of x, not the negative one. The positive one is going to be the time when it hits the ground. So I'm going to subtract 51.5 over. I'm going to divide both sides by 5. Now this should be some exact number here, or by -5. 51, it'll be a decimal, but 10.3. It's actually a cleaner decimal than I thought. Take the square root. Normally we'd say plus or minus the square root, but here we're concerned about the positive one, and add 3. So x equals 3 plus, I was about to write plus or minus, 10.3. Now 3 plus 10.3, or square root of 10.3. 3 plus square root of 10.3 is 6.21 about. It says 209, something like that. So 6.21 seconds, and I believe that number because here's the thing about these ones. 3 seconds in, they reach their maximum height, and they release with the height above 0. So 6 seconds later, they're going to reach like 5 seconds again, or in this case, 6.5 seconds again. And just past 6 seconds, it'll reach that. It's doom. It's demise. Now, so the second ball is there. Suddenly, I'm deciding whether or not I should continue answering that question. Well, actually, I don't know if these are going to reach the same destination. So actually, let's keep going. So that's the second ball. Now I got all this room to do it for the first ball. First ball, guys, we still need to come up with an equation. So the first ball equation, we still have to, I can use vertex form here. I got a vertex here. I have a point that it crosses through here. We can do the same stuff we were doing before. Y equals A times X. Oh, let's do X minus H, quantity squared plus K. So substitute 5 for Y and 0 for X. 5 equals A times 0 minus 3, negative 3 quantity squared plus 56.5. 5. This becomes negative 51.5 over here when subtracted. Negative 3 squared is 9. So A here is, this is going to be a clean number? No. So I'll just write negative 51.5 over 9. If I double negative 51.5, so I don't have a weird fraction, I get 103. So negative 103 over 18. No one's favorite to look at. But this equation will be Y equals negative 103 over 18 times X minus 3 quantity squared plus 56.5. Okay, now we got to set this one equal to 0 as well. I doubt these are going to land at the same time, but they'll be pretty close. We're going to subtract 56.5 over. I'm going to divide both sides by negative 103 over 18, which is multiplying both sides by 18 over negative 103. So hopefully I haven't messed up any numbers here. 56.5 times 18 divided by 103 is not a perfect number, so I'm going to leave it as this fraction. X minus 3 quantity squared equals, this is 1017 over 103. So X equals, I'm going to add the 3 as I take the square root. 3 plus the square root of 1017 over 103. If I didn't mess up any numbers along the way, this should be a number that's just beyond 6 as well. So 3 plus the square root of 1017 divided by 103. It's kind of a weird model for a question. 6.14 seconds. So I'm going to trust the number at the very least, which means 6.14 compared to 6.21. The second ball traveled a little, or stayed in the air a little bit longer, despite the fact it didn't go as high in the air. I guess it's, and I don't know how that works as far as, I guess spin rate kind of keeps it up in the air longer, but the second ball is in the air longer by 0.07 seconds. Okay, so is that all they asked? They said which one's in the air longer? Do the balls hit the ground at the same time? How long are the balls in the air? All right. The first ball is in the air for about 6.14 seconds. And the second ball is in the air for about 6.21 seconds. So the second ball is in the air longer. All right. Let's keep going forward. Number 3. The paperclip is made from, this looks like chapter 1. The paperclip is made from a cylindrical metal wire with a diameter of 1 millimeter. The density of the metal is about 7.8 grams per cubic centimeter. Let's write that. Density is 7.8 grams per cubic centimeter. Approximate the mass of the paperclip to the nearest gram. Explain your procedure. Well, density is mass over volume. We have density. We need volume to get mass. Okay, that's our basic premise of the explain your procedure. Our volume, here's the thing. I see these numbers and they're in millimeters because this is per cubic centimeter. I think it's important that I convert all of these numbers to centimeters from millimeters. Now, it's 10 millimeters is 1 centimeter, correct? So I think we have to divide these all by 10, which means just a decimal shift on all these guys. Let's see if we can keep that in mind. So this will be 4.1 centimeters. This might get a little messy looking. 2.4, 3.1, 3.1, 0.6, 0.8, and 0.7. Can we keep those in mind when we do all this? Now, that's a lot of different things to do. This volume of this thing, and we've talked about this one before as well, is more or less an approximation. Geez, what was the width? 1 millimeter width of this. I believe it for paper clips. It's very small. So 1 millimeter is also 0.1 centimeters. Now, the cylinder, imagine this is the cylinder of the paperclip, just a portion of it that's kind of cut off right there. That's a 1 millimeter diameter. So that means the radius is 0.05 centimeters. It's half of 0.1 centimeters. So when it comes to volume of this thing, imagine we took the whole paperclip, which is what I do with paperclips all the time, and you bend it all so it's all straight. We have to find the volume of all those different pieces. I'm more inclined to look at probably the straight portions first and add those all together. Then we'll talk about the curvy portions as well. So this might take a little bit of time and just, processing and planning out. Even I got to talk through it and look at it as a whole. Now, the radius is a big part of this because volume of a cylinder, I don't know how to move this without giving up too much space. The volume of a cylinder is area of base times height. So volume is area of base times height, or pi r squared times height. Now this height would be everything if you stretch it all out. Now suddenly I'm deciding whether we should stretch it all out as one single height before we add them all together. How do they do the curve parts? You average those two parts. You average their two circumferences. So let's get the height as one big total thing. We have 4.1, I'm looking at the top. We have 4.1 centimeters. Plus, I'm going to kind of cross things out in red. Plus 2.4, remember these are in centimeters, plus 2.4 centimeters. Plus 3.1 centimeters. Plus 3.1 centimeters. So these are all the straight parts, I believe. Okay? They have... I'm trying to make sense of this as well, so give me a second. We covered this straight part, this straight part, this straight part, and this straight part. We're now left to this curvy part, and this curvy part right here. Now, what they're showing us are inner widths of some of these bends in the paperclip. And what we're doing is we're comparing... This says 7 millimeters on the outside here. Oh, I get it, because the diameter is 1 centimeter thick. That means if that's 7, then this is 5. They're really leaving a lot for us to do here, or 0.5 centimeters, right? So what we have to do is we have to average the circumference of this 0.5. That's a diameter. There's a lot to do on this problem, guys. I'm going to draw this stuff down below. So I have a curve on the paperclip, right? This thing turns around right here. On the outer portion of this thing, the outer portion is 0.7 centimeters on one of them. The inner portion is 0.5 centimeters. What we have to do, because these are like semicircles, I have to find the circumference of this, and average those two circumferences. Now, circumference is diameter times pi. So the circumference of this one, hold on, because that's the part we have to find here. So the circumference of the outside one is 0.7 pi over 2, which is 0.35 pi, because it's diameter times pi and half of it for a semicircle. The circumference of the other one is 0.5 pi over 2, which is 0.25 pi. We have to average these two numbers and divide it by 2. Circumference average is 0.35 pi plus 0.35 pi plus 0.25 pi divided by 2, which is 0.6 pi divided by 2, which is 0.3 pi. This is centimeters. So the average track around this is 0.3 pi. We're going to add that. Okay? That's one of them we have to add. Then we have two more to add. We have to average the 6 and 8 millimeter ones. I don't know if there's a trick to this. I don't know if I did that right, but it's just averaging circumferences. Maybe I can just average. Okay, I think I can just average 0.7, 0.5, and then divide that by 2 and multiply by pi. So I think we can do this for this one here. So 0.6 plus 0.8 divided by 2 times pi. Oh, and divide that by 2 as well. So I'll say divided by 4 times pi because it's a semicircle. We're not only averaging, we're also doing semicircle distance. So that'll be 1.4 pi over 4, which is not a very clean number. Let's see. 1.4 divided by 4, 0.35. 0.35 pi. Nothing that I'm doing is going to be very organized. I don't trust that anyone is following along with me in full here. This is a little tricky, but I found the average of those two in the inside track right there. Why am I doing averages, you might ask? Because we're bending this thing out straight, and the bend of one and the bend of the other is kind of averaging, showing how those heights kind of work as an in-between. That's a goodie average on that. Now, the average of this one is going to be the average of 0.6 millimeters here and 0.4 millimeters there. You have to centimeters. You have to remember that the thickness of the paperclip is 1 millimeter each, so that 0.1 centimeters and that 0.1 centimeters are taken away to give the 0.4. So it's a courtesy that they gave you that before. So average 0.6 and 0.4, whereas you divide it by 2 to average it, but then you got to divide it by 2 for semicircle, which means we divide it by 4. So that's 1 pi over 4, which is 0.25 pi centimeters. So we're going to add 0.25 pi centimeters as well. And in total, when you add all those together, there are some in terms of pi and some that are not. Let's do those. 4.1 plus 2.4 plus 3.1 plus 3.1, that's 6.2, is 12.7. So this is 12.7 plus 0.3 plus 0.35 pi plus 0.25 pi. That should be 0.9 pi, 0.9 pi centimeters. So this is the height. This is the height of our paperclip, in my view, and I'm not rounding just yet. Okay, so now we got to find the volume of the whole paperclip, which is area of base times height. We got that pi r squared. Radius was what? 0.05 centimeters. So pi times 0.05 squared times height, 12.7 plus 0.9 pi. Yeah, now is the time to probably do some rounding, right? So let's go to the calculator for that. We're going to do pi times 0.05 squared times, whoops, I'm doing stuff in the calculator now, times 12.7 plus 0.9 pi. Okay, so this volume, this is in cubic centimeters, by the way. I'm going to write just the first few decimals, 0.122. It's got more on the calculator, 0.12195216, whatever. So our density was, I think, 7.8. So we're going to say 7.8 is mass over 0.122. So mass is 7.8 times 0.122. And remember, I have the exact answer on the calculator here, so I'm just going to do that times 7.8. And remember, this is going to be in grams. A paperclip is very light. It's 0.95122. So 0.951 grams, about, close to a gram. I mean, that makes sense as an answer. I believe it. Paperclips are very light. I don't know how much a gram is, but it doesn't seem, like a dollar bill is about a gram. So a paperclip about the weight of a dollar. Oh, it says to the nearest gram. Let's say about 1 gram. And anyway, my procedure is clearly laid out here. My procedure was density is mass over volume. Find the volume in terms of centimeters or cubic centimeters. Average out these tracks of the 3 arcs and add them with the straight parts to find the overall height of a cylinder that is now straightened out. The paperclip is now straightened out in that way. and do volume of that and work it out in that way. So that's my procedure. I'm sticking to it. Let's move on. Number 4. Gym A charges $10 per month plus an initiation fee of $100. Gym B charges $30 per month, but due to a special promotion is not currently charging an initiation fee. These sound like linear equations. Write an equation for each gym modeling the total cost Y for membership lasting X months. Yeah, Gym A, I'll call it Y sub A. The cost, $10 per month plus an initiation fee of $100. Gym B, flat rate $30 per month, no initiation fee. All right, those are the 2 equations. That's part A. Part B. I don't even know what section this would be out of. When is it more economical for a person to choose Gym A over Gym B? Well, the idea is, where would you be spending less? See, you're spending less on Gym B to start off with, because you start off with a $100 cost. If you go 1 month in on Gym A, you're $110 deep. 1 month in Gym B is only $30 deep. You could do a table to figure these out, but what I really should do is just set these equal to each other and find out for what value of X, at what month are they equal, basically? Or does one surpass the other? So subtract 10x, you get 20x equals 100, and you get x equals 5. So 5 months in, you get a tie in terms of membership cost. So Gym B is more economical for the first 4 months, and Gym A becomes more economical after 5 months. Because at 5 months, they're the same. So after that, the initial $100 you spent pays dividends later when you only do $10 a month after you've spent, I guess, $150 at each of them. All right, part C. Gym A lowers its initiation fee to $25. Describe the transformation this change represents and how it affects your decision in part B. So the original Y sub A would have been 10x, was 10x plus 100. And now Y sub A new is 10x plus 25. They say they lowered it to $25, not they lowered it by $25. So the transformation is $75 less. It's a vertical translation. That sounds weird. Vertical translation, $75 down. I don't really know how I said it. Hey guys, we vertically translated our price, $75 down. Now it says, how does it affect your answer in part B? Well, Gym A is now going to be more economical a little bit faster here. So how it affects your decision, let's set them equal again and figure out what's going to happen. So now 10x plus 25 equals 30x. And now 20x equals 25. Now x equals 25 over 20, which is 1.25. By month 2, by the second month, Gym A becomes more economical. By the second month, Gym A becomes more economical. Just means you're spending less. Because at month 1, Gym B is somewhere within the month. There's a change. Anyway, that's part C. And that's it. Whoops. Number 5. Let the graph of G be a translation 3 units right of the graph of F. The points -1, 6, 3, 14, and 6, 41 lie on the graph of F. Which points lie on the graph of G? So 3 units to the right. Let's look at F's points. F has the following 3 points: -1, 6. I'll express my concern in a bit. We'll see if there is one. 3, 14, and 6, 41. My concern is that I'm going to have to find out its equation in standard form to find other points for G. What I'm going to look at on these points is, do we have points that we go 3 to the right? -1 plus 3. 3 to the right is adding 3 to the x's. -1 plus 3 is 2. Is this one of my options on here? 3 plus 3 is 6. Is 6, 14? Because these are points on G. The question is, are these among my options? And add 3 to this one and you get 9. 9, 41. So these are 3 points for G. Are they on here? 2, 6 is on there. That's A. Okay. 6, 14 is on here. That's C. And 9, 41 is on here. That's E. Now, the other 3... Oh, Okay, I see what they did. They either added 3 on X or added 3 on Y. Now, this is impossible to be on G because you can't have two Ys for the same X. 614, 619, that's impossible, and that'd be impossible. Okay, so A, C, and E. A, C, and E. Those are the ones. That was kind of a weird question. I think it's just asking, do you add 3 to X or add 3 to Y? You add 3 to X. They could have made it much more difficult had you found the equation in standard form and then had to plug in numbers for X to find the Ys that would match it. So I'm glad they didn't. All right, number 6. Draw a two-dimensional figure and an axis that produce a cylinder with a volume of 48 pi cubic feet when you rotate the figure around the axis. This was section 1. Cross sections was 1.3. I think this was section 1.4. So to produce a cylinder, you need some sort of rectangle or square around an axis. So I could do something like, like this right here. But they need specific numbers, right? If I have a rectangle right here, rotating it around this axis would produce, rotate it around, would produce a cylinder, like that. We need the cylinder to have, let me thin these out a little bit. We need the cylinder to have a volume of 48 pi cubic feet. Now it says, draw a two-dimensional figure that produces this. This sounds very open-ended, so we can come up with some stuff. What we need is for our volume, why won't this move? Excuse me. Okay, I'm trying to move it. I guess I just have to drag it. This is really strange. Okay, I can't really move it. Okay, anyway. What I need, this essentially becomes my radius. When you consider this revolution thing right here, right, this is the radius. So my radius here is R. This is the height of the, again, when you draw this here, this is the height of the cylinder, like that, okay? So here's my R, here's my H. I need my volume, pi r squared, times height to equal 48 pi. When I divide both sides by pi, they cancel out. I need my r squared times h to equal 48. I guess there's not much more I have to say on that. It's just these are the dimensions they say. Draw a two-dimensional figure, So this two-dimensional figure, I have to come up with these numbers. So I can make things up, right? I just need to make sure that r squared is h over 48 or the other way around, whatever. So I can make up numbers as I go. Let's see. If r squared is 48 over h, let's get a perfect square out of that if I could. 4 is a perfect square. Okay, we can divide by 12. So if I said r squared is 48 over 12, then I could say that r squared is 4, therefore r is 2. So I could do a height of 12. This is open-ended. So I'm going to do a height of 12 feet. This is cubic feet. And a radius of 2 feet. So this would work here. So it's a rectangle. Keep that there. This is a rectangle that when revolved around there should give me a volume of 48 pi. Pi times 2 squared is 4 pi times height. There is 48 pi. Yes, that works. All right, there's my answer. This is the axis of revolution, and that's the rectangle that revolves. All right, number 7. You make DVDs of 3 types of shows: comedy, drama, and reality-based. An episode of a comedy lasts 30 minutes, while a drama and reality-based episode each lasts 60 minutes. The DVDs can hold 360 minutes of programming. You completely fill a DVD with 7 episodes and include twice as many episodes of a drama as a comedy. Create a system of equations that models the situation. I'm trying to find the third equation here. One of the equations is the DVDs can hold 360 minutes of programming. So I'm going to first define variables. I generally type this out. I'm going to let x equal comedy. Is this number of episodes? Yeah, whoa, what did I type? Number of comedy episodes. Y equal number of drama episodes. And Z number of reality-based. I'll say reality-based episodes. Okay, so one of my equations that I can write is the minutes one. A comedy lasts 30 minutes. 30 minutes per comedy times the number of comedies, plus 60 minutes per drama times the number of dramas, plus 60 minutes per reality show times the number of reality shows. That equals 360 there. Oh, 7 episodes. I didn't see that one. So X plus Y plus Z equals 7. 7 total episodes there. I missed that sentence. The other one is you include twice as many episodes of a drama as a comedy. So the number of dramas equals twice the number of comedies. So there's my system of 3. That would be part A. Part B. How many episodes of each type are in part A? Now we have to solve this system. I'm going to use substitution. I got 2x that can go in for y here and here. By the way, on my first equation, I can divide everything by 30, and that'll give me x plus 2y plus 2z equals 12. Don't tell me that dividing doesn't help you ever, because it totally does there. But I'm going to plug it into that one, I guess, now. So in part B, I have equation number 1 rewritten now as x plus 2y plus 2z equals 12. X plus 4x plus 2z equals 12, or 5x plus 2z equals 12. Equation number 2 is rewritten as x plus y plus z equals 7, or 3x plus z equals 7. So I have these two equations here and here that I can now use to solve for some stuff. If I multiply the bottom equation by -2, now I'll have 5x plus 2z equals 12, and down here I'll have -6x minus 2z equals -14. The z's cancel, and you're left with -x equals -2, or x equals +2. There are 2 comedy episodes on the DVD. To solve for number of, what are the dramas? Y equals 2x. There are twice as many of those, so 2 times 2, so y equals 4. So x is 2, y is 4. And 3x plus z equals 7. 3 times 2 plus z equals 7. 6 plus z equals 7. Z equals 1. Yeah, you only need one reality-based show on this. Come on. So, to answer the question of how many episodes of each, there are 2. I like that question. There are 2 comedy episodes, 4 drama episodes. This is probably how I'd do it. I'd have no reality-based, and only 1 reality-based episode. All right. There's part B. Excuse me. Part C. You completely fill a second DVD with only 6 episodes. The 2 DVDs have a different number of comedies, dramas, reality-based episodes explained. Well, is everything else the same? So, oh, you completely fill a DVD. Oh, wait. So you completely fill, so now your x plus y plus z equals 6. You still need something to add to 360. Oh, I don't know if we have to solve a system. I think we just need to make sure it still completely fills. So let's see what we did before. Before we had 2 comedies, 4 reality shows, 4 dramas, and 1 reality show, which equaled, we probably wrote it the other way, but equaled 360. Now we're going to reduce this to 6 episodes, which means we have to take out 1 of something and replace 1 of something with something else. Listen, for 6 episodes, they need to all be 60 minutes. Otherwise, this won't work. You have to take out both comedies. Take out both comedies. I don't know if this is answering right, but you completely fill a second DVD. It needs to hold 360 minutes. So, you need to remove both comedies, or all comedies, and either replace and either add 1 extra drama or 1 extra reality show. I don't know if that kind of answers that right, but it just says the 2 DVDs have a different number of comedies, dramas, reality-based episodes. So they could. The comedies, definitely, yes. And then one of the other ones will change, so I'm not sure which one. But it needs to add to 360 minutes with that in mind, and that's the only way that that's possible. So, anyway, you can have, or listen, you can change the number of drama. You can do anywhere between. You don't need to add this, but you need to remove both comedies. So let me change this. They didn't say that the dramas and reality shows need to start with 4 and 1. You can have anywhere between 0 to 6 dramas and 0 to 6 reality shows so long as there are 6 episodes, 6 of those in total. I think that's it. So the comedies will absolutely change. These may change slightly, all depending on what that is. And I guess that's the way I can best explain it. It's just each thing needs to be 60 minutes if there are only 6 of them. So you default to 360. All right, number 8. 3 more questions here, but number 8. The graphs of f and g intersect at 2, -2. Whoops. Explain how you can use this point to find the solution to the equation f of x equals g of x. Extend the tables to justify your answer. What? The solution. If they intersect, then that is the solution. The intersection, the point of intersection is the solution of the equation. F of x equals g of x. F of 2, sorry, f of 2 equals g of 2 because -12 equals -12. I don't know what they're saying. They're saying they intersect there. Well, listen, they want us to extend the tables. Basically, what should be happening, this is just like that gym membership one. At 5 months, they should each be $150. At 2 for X, they should each be -2 for Y is basically what we're saying here. So let's extend the tables. I don't know if what I'm writing to begin with works, but that's what solutions are when the left side equals the right side. There are also points of intersection for these things. So the first one is -5, -4, -3, -2. We have to go to 2. So -1, 0, 1, and 2. All right, this has a linear relationship. We're adding 3 each time. -17, -14. So we're adding 3. So -11, -8, -5, -2. Okay? Now this next one starts at -2, -0, and 1. Oh, -2, -1, 0, 1, and 2. This is also linear. They're adding 4 each time. -18, -14, -10, -6, and -2. I don't know what they're asking for, but f of 2 is -2. G of 2 is... Sorry, I put -12. I meant -2. F of 2 is -2. G of 2 is -2. Therefore, they intersect and they are solutions. I don't know what else to say. I'm tapped out on that problem. That's it. Number 9. You are building a rectangular deck against a house. You want the deck to have an area of 200 square feet. Draw a diagram of the deck, including the location of the house, that minimizes the amount of railing you would need to build for the 3 sides of the deck, not against the house. Include a 4-foot wide opening in the railing for stairs. How many feet of railing do you need? So I'm imagining, I'm going to not draw the actual thing yet. I'm imagining a house here and then like a deck. They said stairs. So if like a deck sticks out of the house right there, the stairs have to lead up to it. So the gate's like there and they talk about railing. So the deck is up higher. It's raised basically. It's not on ground level or, it's a few feet above ground level. Okay. So let's draw it from the top down. So I have a house. This is from the top down. I got a house. And I have a deck that's built against a house. So some sort of deck. Now somewhere in this deck, I need an opening for a gate that's 4 feet wide. I have to understand this question here in a bit. So gate. This is 4 feet. Okay, what do they want? What do you want? Draw a diagram. The deck needs to have an area of 200 square feet. Draw the diagram, including the location of the house, that minimizes the amount of railing you need to build for the 3 sides of the deck, not against the house. Okay. So let's call these widths and length. I can't guarantee which one's longer, which one's shorter. And technically you need an L minus 4 there. But I need my width times my length times width to be 200. And I want to minimize W plus L minus 4 plus W as perimeter. So perimeter is 2W plus L minus 4. I want to make that as small as possible. Now, if I rewrite one of... I'm not really sure what to do. Now, if I rewrite one of these in terms of just L or W, let's do like... I don't know which one's easier. W equals 200 over L. Then I can do perimeter equals 2 times 200 over L plus L minus 4. If I get a perimeter, if I get a common denominator, so that's 400 over L, I can call this L squared over L and minus 4L over L. So perimeter is now, I'm just thinking this out loud, L squared minus 4L plus 400 all over L. And I'm trying to, I guess with an L there, but there's an L on the bottom. I'm trying to do something to minimize that. I would think in terms of quadratic, but this L is here. And that doesn't make it quadratic. It actually makes it rational, linear and rational. How many feet of railing do you need? Is that a 4-foot wide opening? Let me think about what to do here, because that's not actually quadratic. If I wanted to minimize it, I would think about... let me see what this looks like on a graph before I do anything else. X squared minus 4x plus 400 over x. I can't even see it on the graph. The window is way too far out. Let me pause this and look at this for a second. Okay. I'm a firm belief that what I'm doing is fine. The thing is, I feel like I got to use a calculator for the answer on this one, unless we're planning on using calculus, because we can't do vertex stuff with this as long as that L's in play. It's not, because this is a rational function. It's not a other thing. So here's what I was doing on my calculator, okay? I wrote this equation out right here. I used x instead of L. So L squared minus 4L plus 400 over L, you know, that kind of thing. And I'm trying to tweak my window range here. I'm going to find a better one for you. I'm going to extend this out 50 and maybe 80 or something like that. There's a bigger curve going on. I'm not going to explain it, how this curve works, but here's this bottom part where it gets to the bottom. And I want to find out where this thing minimizes, but you can tell it's not a parabola. It's actually a rational function. Again, I'm not going to explain it. But to find a minimum here, you have to hit calc and go to minimum on this guy. So the minimum of this one, I have to go somewhere just to the left of the minimum and to the right of the minimum here. And then I can guess it. I got to hit enter a couple times here. So to the left and right and guess. And the minimum value here, okay, that number should probably say 20, right? It's doing something. It's probably because of the calculator pixelation. I think it wants to say 20. So my L in this case should be 20. That minimizes this thing. The Y of 36, I think that's the perimeter. I think that minimizes the perimeter at 36. We can take a look at perimeter afterward. But the L that we need here is 20. Now keep in mind that L is a part of, L is this entire thing, right? The 4 feet right there would take out some of the length. So my whole, well, I have an expression for my perimeter right here. I guess that would be 36. That would help me out. So what was the overall question that they asked? How many feet of railing do you need? So I think 36 feet. Because based off that diagram, I think that's what it's going to be. So I assume that's what the calculator was doing. Let's go back to the original perimeter equation, though. Width is 200 over length. Width is 200 over 20, which is 10. So 10 feet. Your length is 20 feet. As a diagram, though, you have to remember the 4-foot opening. We have house. We have deck with an opening. So this is 10 feet plus 10 feet plus 20 minus 4. So here, let's put the deck in the corner. So 20 minus 4 would make that 16. Yeah, 10 plus 16 equals 36 feet. Of course, I had an expression for it right here The 2w plus L minus 4, that would give you the same thing, the 36. I just wanted to show you how that drawing would break that thing up. So yeah, I'm going to use my calculator to minimize that one. I think that that's all I really could do with you guys on it. They didn't really express that, but based on what I did with my expression on that, that's all I could really think about. So let's go with it. All right, I got one more question on number 10. Order the cross sections of the planes intersecting the rectangular prism from least area to greatest area. The length and the width of the prism are equal. So it's a square prism. They called it a rectangular prism if the length and width are equal. Okay. A is going by, assuming the height's taller, I guess. A is going this taller height times some length there. This is even longer than that times that same thing. And this is two short guys right there. So from least to greatest, C is the least, A is next, and B is next. They don't say explain it, so I'm just explaining to you out loud. Assuming the length and width are smaller than the height, length times width is going to give you smaller than, say, width times height. And then this guy slanted is longer than the height, just a Pythagorean theorem kind of note there. That would be the longest. So it'd be C, A, and B. Didn't need a whole nother page for that, but I think that's it. All right, guys, and that'll do it for this one. This is Mr. Robinson. Thank you so much for watching, and that concludes all of Chapter 2. Yeah, some of these questions were weirder and harder, and they even threw a wrinkle for me, so I hope that all panned out just fine. Thank you. Take care. I'll see you in Chapter 3.